Alright, welcome back to the loops slides. We're going to finish them up and then start some new ones. The last thing we talked about was nested loops, which is quite difficult to first learn, I know, but we can do some very cool stuff with nested loops, right? Some very fun facts, including drawing boxes. I want to go further with this box drawing idea because we could do fancy things and draw hollow boxes. We could take that all the way to turning our terminal into a graphing calculator. All right, so I want to show that too. Let's graph a circle on the terminal. All right, so here's your terminal. Normally, when you open a default sized terminal, it is a certain number of characters wide by characters tall. It's usually the default on most terminals is the width of your screen of your terminal is 78-ish characters, and then the height is 24-ish characters. So let's say that is our canvas in which we would like to draw a circle, and essentially it's just think of it as a big box of stars, right? We drew a big box of stars and we want to pick out only a circle's worth of those stars. Yeah, so here's my best artist rendition of a circle made out of stars, and then everything else is empty space, just like the hollow box. Remember that example? So that's what I want. That's what I'd like to do. And it's just gonna take me, right? All I need to really do to make this happen is fill in 78 by 24 characters, right? That many characters with some spaces and some stars. So in essence, let's start with just a 78 by 24 box of stars and see how far that gets us, right? Because it's just, we need to turn some of those stars into spaces. That's pretty much it. So let's say that is our graphs window. Let's assume it's 78 by 24. I might have to zoom out because I like to zoom into my terminal so you can see it big, but we'll get there. All right, so let's make a new program called graph.cpp. And I'm just going to make a 78 by 24 box of stars, and then eventually we're going to pick out the equation of a circle of a certain radius, right? That's the equation of a circle. But let's see how far this gets us. Let's be all right, for int I equals 0, right? This is how I like to do it. I is less than, I just want a loop that iterates, right? 24 times. 24 times because I is worrying about which line we're on, right? So I got 24 lines, so I is less than 24, I plus plus. And then I want to print exactly 78 stars per line, and then a new line, right? 78 by 24 box, exactly the stuff we were doing before. Int j equals 0, j is less than 78, right? J plus plus, and so then print a single star, and that'll finish off the line. So cout endl, and that should do it. So that's going to give me a box of stars that's 78 width and 24 height. And I'm going to have to zoom out when I run this. Oops, let's not call that graph with a dot. I want to call it graph without a dot. There we go. So when I run it, I legitimately do get a 78 by 24 box of stars if I zoom out far enough. Whee. There it is, okay? And so that's my canvas. I want to draw in that canvas and turn a lot of those stars into spaces, right? Turn it into a circle. That's my goal. But I mean, I've got the window. It's working more or less, and you just need to pick out the stars I really want to draw, don't I? So let's pause and think about what just happened. All right. So when I drew that box of a bunch of stars, if you think about it, right, this I variable is keeping track of which line we're on. That's pretty much like a y, right? That's your y-axis. How far up or down are you? That's your y-axis, isn't it? So let's change I into y. Okay? And then j, similarly, was worrying about which column we're on as we're printing text for a given line. And so that's how far left and right are we, right? So that means j was functioning like x on a graph. Does that make sense? So I've only changed the names of the variables. Nothing has changed really. If I recompile, rerun, I get the same exact output, don't I? So that's kind of cool. All right, I changed some variables. It's working in that way. And my goal is to draw a circle, right? I want to graph this equation, x squared plus y squared equals r squared. I do have x and y now in my program, but I would like this graph, right? It creates a centered circle, doesn't it? Centered at 0, 0. So right now, y is going from 0 to 24, so it's kind of going backwards. This is y equals 0 right now, this is y equals 24 right now. And then same for x. X is going in a weird way. I guess it's going in the right order at least, but like this is x equals 0 all the way to this is x equals 77 right now. So that's not good enough. I'd like 0, 0 to be in the middle of the screen. Okay, so let me change, right? Let me change how my variables are iterating, because this is what I want. I want that 0, 0 for x and y right there, smack in the middle of my screen. That's where it should be, right there. That's what I want. And so I just need to change the way that y and x are like moving. I just need them to still go 24 and 78 times, but they should be centered, right? The middle right here should be y equals 0. That's what I want. Okay, y equals 0, and then this one should be x equals 0. If you think about it long enough, just like, all right, I want to center y equals 0 here. I'm forced to start on this line, like what is just like 24 over 2 essentially. So it's 12. Let's say that y equals 12 is the very first line. We'll start y at 12, because then it'll work its way downwards, right, to 0 all the way to, I guess, negative 11. All right, so that's going to be, y will range in that way down on this way as the loop is progressing. All right, so it's still going to iterate 24 times. I'm still going to get 24 things, but 0 now is in the middle. I hope that makes sense. All right, so that's the first thing I need to change. So y needs to start at 12. That's the very first y I want to care about. And y should keep going as long as it's greater than or equal to negative 11. And so then it's y minus minus. Does that make sense? It's still going to iterate exactly 24 times, but just like y equals 0 now is the middle of this iteration. Okay? I want to do the same for x. So like if I want x equals 0 here, I can't start x at 0. It needs to be like some negative number. So think of 78 over 2 essentially. So like this can be x equals negative 38, and then we can go all the way to x equals positive 37. All right? Because it's even, you have to kind of like not straddle it perfectly, but that's good enough for us. So I'll start x here and have x progress all the way to 37. It'll still go through 78 values, but now 0's in the middle. All right, I'll prove that to you. That's something I want. So negative 38, go all the way up to, let's see. Oh, sorry, not 37. It was supposed to be 39. Excuse me. I did my math wrong. That should be 78 now, okay? I think that's what I wanted to do. Yeah, that should work for us. All right. And x can still go in that order. But again, all I've done is changed how these variables iterate. I've changed the values that they go between. I haven't changed what they do. Right, so if I run it again, I get the same exact output. Was I off? I think I was off. So let's do this right. Let's see. It wasn't 38 and 39. It must have been what's 78 over 2? It was 39. Shoot, should it have been then? Let's just keep it how it is. I don't want to do too much extra math. I think I accidentally made this longer, but it's still 0 is in the middle. All right, good enough. Good enough for our purposes. And so let me prove that to you. So when I run it, morally it should have been the same answer, same graph. And now 0, 0 is somewhere sitting right here instead of like, I guess it was over here before. It was like at the top left. So let me prove that to you. I need to zoom out so you can see the whole thing. But let's ask it. Let's be like, all right, if x is 0 and y is 0, then instead of a star, I'm going to print the axes meeting. I'll print a plus sign, all right? And then otherwise, if it wasn't like the axes at 0, 0, then I'll print my star normally. So watch. I have now centered my graph. Do you see the beautiful plus sign? It's lovely. All right, so that's great. That's exactly what I wanted. Awesome. And now I can graph, right? So now it's centered. Essentially, I kind of want to do the same thing for all the other places. For the equation of the circle, this was like the axes meeting. And then this is what I want to compare when like it's 0, 0. I hope that makes sense. Okay? So yeah, that is the right range. That is the right range, I think. And yeah, now I just need to pick out the places that are on the graph. Does that make sense? That's going to be the secret. So yeah, I've got pretty far now. Let's talk about graphing the circle. So let's pretend that we want to graph a circle with a radius 10. All right, so that's going to be x squared plus y squared equals 10 squared. That's the equation of that circle I'd like to graph. And so like, if I want to graph that, I need to like figure out which of those coordinates are part of the circle. And I'm trying a bunch, right? That's part of nested loops, right? It's trying every combination of x and y values. I just want to pick out the ones that are on the graph, don't I? So that's what I would like to do. Like this is my final goal, like draw the axes meeting and then stars around the circle. So I want to pick out all the points where x squared plus y squared is equal to 10 squared, essentially. All right. So in order to do that, that's what I want. And you can more or less, like you could kind of turn this into an equality check and see if it works, but it won't always. All right. So there is a bit of a different equation that we have to deal with. All right. So it just so happens that x and y right now, they're ranging through whole numbers, integer values. It's not usually the case that x squared plus y squared equals 10 squared where x and y are integer values. It'll work, like if you try to graph it exactly like this, like with a double equals, it will kind of work for some points, like all the edges I think will be correctly at a whole number for coordinates, and then you might get like 1 or 2 in the middle here or something. But like most of these points that are on the circle, right, they have nothing to do with whole number coordinates, do they? And that's all I'm dealing with right now. So I do have to be a bit fancier, all right? I want to check, like the goal is to check, like I'm ranging through all these xy values, I want to check if it's on this graph right now and print a star if it is, but I kind of want to rewrite the equation in a way that's going to confirm and make sure that there's always going to be at least one point, at least one y value for every x value. Like bring it to the closest thing, even if it's not a whole number coordinate. All right. So for silly decimal reasons, because I want to do something like that, I want to make sure that there's always a y for every x. I want to solve this. I'm going to solve this equation for y. All right. And if you do that, that becomes like y squared equals 10 squared minus x squared. And then to get the y squared to go just to y, you got to take the square root, right? So y equals the square root. And because you took a square root, it's going to be y is equal to not just the normal square root, but it's plus or minus the square root. All right, so that's how you solve for y and graph a circle. So there's actually 2 equations that we get out of that. I hope that makes sense. And yeah, for weird decimal reasons, we can't just like check this. Let me prove that to you. So here, let's try. Let's be like, all right, we care if it's on the graph. If x squared plus y squared is equal to 10 squared, which is 100, or we could just check that, then I want to graph a star. Otherwise, it might be the axes meeting. Otherwise, it's just empty space, not part of the graph I care about. Does that kind of make sense? That's what I want, and you see it kind of works, but a lot of these pieces of the graph are missing because these are just like not whole number coordinates. It's not perfect. There are some decimals at play here. All right, so but we got kind of far. That's kind of neat. So this is like, that's the circle in a nutshell. So because of decimal issues, like there should probably be a star like right here or something, but like it's not perfect. So we kind of want to force it. We want to make sure that there's always a y for every x. All right, and when you solve for this equation, that's kind of what you're doing. All right, so that's what I would like to have happen. Like we get something that looks like this. Like we get some stars right now, but not all the ones. We want to make sure like for every x, there's always a y. We'll just like nudge it. If it's not perfectly at an integer coordinate, we're going to make sure it's at an integer coordinate. We'll round. All right, that's what we'll do. So that was a lot of words. Kind of what I mean by this is we want to kind of program this. X, Y, it needs to be plotted. It needs to be on the graph if it's very close to being on that circle, essentially. It needs to be plotted if this is true. All right, if this is true. If y is equal to not just exactly, right? If not just y is equal to the square, this is the top half right now of the circle. Y is equal to the square root, which is sqrt, right, of 10 squared minus x squared, so that's 10 times 10 minus x times x. You don't want to check and plot it only if that's equal, because the square root of numbers is usually not a whole number, right? I'm only ranging through whole numbers right now. Whole number x and y coordinates. So what I'll do to fix this is I'll just round it. Let's give me the closest one. Just give me the closest y for every x. For every x, give me the closest y, I'll round it. That's what this will confirm and make sure. this happens. Okay, so the moral of the story is I need to squish my my coordinates of my circle onto integer things. All right, need to squish decimal places, right? Because usually the square root has decimal places. I need to squish those decimal places up or down onto integer coordinates. And that will make sure that there's always a y for every x. Otherwise, you'll skip some because it's not perfectly equal, okay? Because we're ranging through integer coordinates only. We'll just give it to the closest one, essentially. All right, and that will give us, this part will be the top half of the circle. So let me change this to be exactly that. So check if y is equal to, I need CMath now, don't I? Check if y is equal to the rounded square root of 10 squared minus x squared. There we go. So that will enforce the idea that we want 1y for every x. It'll just give it to the closest one. All right, and so here now, there's my circle. See, it's forcing it. It's forcing 1y for every x. It's just going to the closest one. So it's a little jagged, but that's better than we had before. Okay, so that's the top half of the circle, and then the negative square root would be the bottom half of the circle. Isn't that cool? So let's see. Let's go back to the code and mark it up now. So that's kind of the idea. Like, it's on the graph if this is true, at least the top half of the circle. And then this one was checking for the axes meeting. And then this one was just like, it wasn't anything important. It's just empty space so that we can get to some future coordinate that's important. We still have to like advance the cursor as we're printing out characters. So that's kind of what's going on there. So that was the top half of the circle. Same exact idea for the bottom half. It's negative square root. So let me do that one now. I guess I'll just kind of forced to add it here, aren't I? So I'll do else if, and it's mostly that. So here, let's do, I think that should fix it all. Let's do the bottom half of the circle. So it's the rounded negative square root. That'll give us the bottom half of the circle. If that's true, we're still on the graph. Still want to print a star. And that should give me a circle. I think it'll work. That's pretty cool. All right, so I hope this is as fun for you as it is for me. The circle is not a perfect circle because every character on the terminal is essentially close to twice as tall as it is wide. So you could account for that by like changing the way that you iterate. You could like go a little bit slower on the x, like go by 0.5 instead of 1. That might space it out better and make it better. But this is good enough for our purposes. I think it's really cool, all right? And hopefully you see the whole point now. Because we do it this way, because usually it's not going to be a decimal coordinate, or it's usually not going to be an integer coordinate. We're kind of forcing every x onto an integer y coordinate, just the closest one. Round it. Give me that one, and I'll plot it, all right? Otherwise, we didn't have it before, all right? So yeah, I think that's really cool, and you can do any equation just like that. Just like graph your y equals the rounded equation involving x. And that will do what you want. I think that's awesome. All right. Yeah, I think that's what I wanted to say. That's a great last example of nested loops. I hope you see how we got here and why the code is working. Please study this. Yell at me if you have any questions about it. It is definitely a harder example for sure, but a good one. And eventually I'm going to give you a lab to do something similar. So that's another reason to want to study it. All right. So now let's switch gears to a new topic. I want to talk about one called arrays and vectors. It's two separate topics, but they have the same kind of idea together. All right, they're doing the same thing more or less. So arrays and vectors, they're fighting each other essentially. The topic here is holding stuff. We want to hold on to a bunch of information. We only have one way to do that right now in code. We can make variables. All right, we can make an int, a char, or a double. We can hold on to one thing with one name. All right. Arrays and vectors give us the ability to do the following. I guess strings kind of do this already, but we can do this with any type, like put a bunch of doubles all together, put a bunch of ints all together. Arrays and vectors do this in memory, okay? And I do want to say right now, I have to teach you arrays so that you can understand vectors. Like vectors is the cool new thing on top of arrays. But I want to just say right now that vectors are the clear winner in this class, at least, all right? Unless you're doing like something really low level, working in a place like on a microcontroller where there's hardly any memory or something, or if you're doing multi-dimensional things, and I'll explain what I mean by that later, then vectors is the way to go. Vectors are much, much better than arrays. They're going to make sure that you don't make any silly mistakes. Arrays do not hold your hand nearly as much as vectors do. We love vectors in this class. They are better than arrays, all right? So I just want to say that at the start, though I want to teach you arrays first because you're going to need them, all right? You're still going to need them and definitely need to know about them. All right, so let's start with arrays, even though vectors are better. So what they do, again, is kind of like this. They hold on to a bunch of things of some type, all right? Because we can't really do that right now. If you want to get a bunch of things, you have to make a bunch of separate variables right now, don't you? Like if this was your problem that I gave to you, if you want to ask, like I tell you to ask the user for 50 numbers and then print out each of those numbers in order after the user gave them to you. This is all you could do right now, right? Make 50 int variables, get them from CN, and then like print them all out. You couldn't even use a loop very easily because all the names are different. Isn't that disgusting? So we don't like that. Wouldn't it be nice if there was a better way? And there definitely is. All right, so arrays to the rescue. Here's what they do. So an array, if you go look up the definition of what that is, it's just like it's a variable, it's something with a name, with one name that holds a bunch of things, a list of things, all of the same type, and each of those pieces inside are directly accessible. All right, so yeah, let me just say some words and I'll draw pictures. So every item inside of an array, we call it an element. All right, and just like for strings, we can get to every individual piece of an array by using indices. So we can index into our array using brackets. All right, so there's not a dot at anymore like with strings. It's going to be little brackets. Okay, so here is an example of how you might make an array in memory. All right, so you say int. You give it a name. So like int is the type of things that lives inside of it. You give it a name, and then between brackets, you put how big you want that array to be. How many ints do you want it to store? So 7, for example. So when you say this, you read it like this, kind of read it a little in a roundabout way, like R is an array, you read the brackets as an array, of 7 ints. Okay, that's kind of how you think about it. So R is its name, R is an array of 7 ints. And in memory, this is what it looks like. So here's R. It's got 7 slots that you could fill with an int right now. And you can get at each of those slots. That's 7, right? You can get each of those slots with indices. It has indices starting at 0, just like for strings. 0, 1, 2, 3, 4, 5, and 6. And they're all filled with garbage right now. Just like with normal variables. You got 7 garbage ints secretly tucked inside of R. Okay, I hope that makes sense. Each of these slots, though, they could hold an int rather than just like a character for strings. So that's very useful. All right, I hope you can agree. So it'll definitely solve this original problem. But let's talk a bit more about that. So yeah, to make an array in general, you say the type of things inside the array, space, the name of your array, like R or whatever. Then in between brackets, you can give the size, how big you want the array to be, how many elements should it have. All right, and then you can start indexing into it with these bracket operators and go to this index I and set it to 42 or get it back. All right, so here, let me draw an example. Like if I say this, int R brackets 3, that's supposed to be an A, by the way. Let me clean that up. So there's int R 3 semicolon. What that does in memory is this. R is an array of 3 ints. Right now they're all set to garbage, but it has indices, 0, 1, and 2 that you could access. All right. And you can change things by indexing into the array with this kind of syntax. You say its name, like R, and then you give the index you want to access, and then you give what you want to set it to. So like that'll replace index 0 with the number 1. Okay, so that will do that. So that's what that syntax does. It indexes into the array. We say indexes into R, and it sets the value there. Just like the .at on strings. Like you could use this to also just get the value as well. All right. So there's that. There is some shorthand. Like you might have to do 50 separate lines if your array is 50 things tall. You could do it all in one line. You can declare and initialize an entire array. You have some options. So you can do it like this. You can give set it, say, equals to, after you give your array, set it equal to curly braces, and then you comma separate all the things that are going inside. So you can do something like this. Int r of size 3 equals curly braces, some stuff, 1, 2, 3. And so that'll fill in all in one go all the elements. They won't be garbage. So that'll declare and initialize them. So r will look like this now. So 1, 2, 3, 0, 1, and 2. That's very nice and useful. And then actually there's even more shorthand, because technically if you give all these values and that's as many as you really want, C++ can figure that out for you. You can just say its name, just give no numbers after the brackets, and just start giving how many things are in it. It'll just like figure out, oh yeah, you wanted 3 elements, that's as many as you get. All right, but you could be very precise if you wanted to, like this as well. So yeah, here's one last example, like double A2, just bracket, and then as long as you give some things between curly braces, this can be an array of doubles, right? So 3.14, 5.67. Then C++ understands that, okay, yeah, you probably wanted 2 here, right? So I'm going to give you just 2 things. A2 is going to be an array of 2 elements. Got indices 0 and 1, right? And then at index 0, it's 3.14. Index 1, it's 5.67. Oops. So yeah, that's arrays in a nutshell. Let's see. Do I want to give you some of that? Yeah, let me, I guess. Let's have an example. I think that would be most useful now. I've drawn a bunch of pictures. I've shown you the syntax. Let's use it all. So here's my demo. Let's get 10 numbers from the user, and then we'll print them back out. All right, so that's an easy problem. Then we'll make it harder. All right, so if I want 10 numbers from the user, let's assume that they're integers. I can declare an array of size 10 like this, right? And be like int r of size 10, semicolon. I don't have anything ready for them, so they can just start out garbage. All right, and that will make r in memory, and I can fill out all of those indices. And I'll show you how to do that with a loop. It'll be great. So okay, we got 10 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so what are my indices? Starts at 0 all the way to 9 then, right? Not 6. There. And so they're all garbage, and we got to fill them in like with cin or something. So here, let's make that code. So let's make space for all the numbers that we're getting from the user, and it's very clean. We can do this in one line now. It's great. All right, so again, you read this as R is an array of 10 ints. Can hold 10 integers. And the valid indices you can talk to and mess with are 0 through 9, right? And so what I want to do now is get 10 numbers from the user to fill in that array with. 10 numbers, fill them in. So get 10 numbers from the user and put them into R, and watch how I can do that with a for loop. I can loop through all the valid indices I want to mess with, 0 through 10. Right? So, sorry, 0 through 9, strictly smaller than 10, I++. Isn't that beautiful? That's super nice. And so now I is going to range over all the different indices I care about. So I is the current, in the body loop every time I run it, I is the current index of R that I'm trying to fill. That's pretty cool. So let's be like cout, enter the next element, colon space, and then I'll be like int next element. I'll get that with cin, and then I will shove into R of I, right? That's the array index I'm trying to work on right now. It gets the value that the user just typed. Boop. So just like that. Isn't that cool? And that'll fill it up. Technically, you don't have to use this extra element value. You could have done it like this. You could have read like straight into R of I. That would have worked as well, but I don't want to confuse you too much with all the syntax. So I'll do it in a 2-step process like this. All right, but that'll fill up the array, and then we just want to go through it again and print out all the elements. Print out all the elements of R, and I can do the same exact thing. For loop through all the valid indices, and this time I'll just go to the indices and not change anything, but look at the values. So I can access R of I for every I, all 0 through 9 of them, and I'll just cout them right? I'll print them all on the same line with a space in between, let's say. And I'll break the line after the loop's done. But that'll do it. That's the relevant code. I hope that makes sense. Do yell at me if you have any questions. Oh, did I say something wrong? Did it? Let's try that again. Oh, no, I guess it was happy weird. And then, yeah, look at it. It's on the first part, so I made the array. Now I'm filling it up. Enter the next element, the next element. So I'll just like type the numbers in order. 10. And then it's got them. Got them all in R now. And then I'm just going to go through R again, print them right back out with spaces in between. Look at that. Beautiful. And of course, it'll print back whatever you typed. You can go in any other order. It'll still give you those numbers back in that order. In the order in which you typed them. That's pretty neat. All right. So yeah, I essentially just did this, but it depends on what you typed, of course. Just remember that your indices start at 0. All right. Let's next get the sum of all the numbers that the user put in this array. Okay. So do you see how we might be able to do that? Again, we want to like iterate through all of the indices, go to each of them, and we'll just start a sum variable. Start it at 0 and fill it in like with each index that I see. Like go to index 0, add whatever you see there into sum. Add the 1 in. Go to index 1, add the value you see in there. So add the 2 into that, so that'll be 3 now. Then go to the next index, add the thing you see there. Make it, I guess, 6, right? Go to the next index, add in what you see there. Make it 10. Just like visit every single index. Once you've done that, put it into sum eventually, right? By the time you've gone to everybody, you've put the total sum in the sum variable. That's going to be the algorithm. So let's make that happen. So if I want to calculate the sum all the elements of the array, I just want to visit every index, but this time instead of printing stuff, I want to like add into a sum variable, right? So like sum equals sum plus R of I, okay? And I can make it a little bit faster with type in by doing this, can't I? Sum plus equals R of I. Isn't that neat? So yeah, that would fill in the sum variable with every value at every index. It'll be perfect. And then by the time this loop is complete, I've visited every index. I've got the value that I want in sum. I've got the total sum. So cout the sum was the sum variable. That's pretty cool. So yeah, let's test it out. I think the sum of all the numbers from 1 to 10 is 55, right? If I remember correctly. Let's do that. 1, 2, 3, 4, 5, 6. Well, you could type any numbers. 8, 9, 10. Yeah, it's going to go through them, and the sum is 55. That's pretty cool. What else could we do? We could also get the average very easily, right? Because the average is the sum over the size. Just remember to use not integer division, right? So the average can be sum over 10.0, right? To force the double floating point division. So let's try that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Cool, yeah, so the average is definitely 5.5. That makes sense, right? 55 over 10, because there's 10 things. Awesome. So yeah, you can see the power that arrays give you. You have a bunch of numbers at your fingertips that you can just work your way through using indices. All right, let's finally get the minimum value. That's the last thing that I want to do. Let me show you the algorithm for that, because it's a cool algorithm. All right, so it's a little similar to sum in that like we want to save the minimum element of the array somewhere outside of the array. So like we'll make a min variable. But now the question is, what do we put here? Like, what do you initialize min first to be? So there is a fancy algorithm to find the minimum as well as the maximum. Here is kind of the setup. So let's notice some things. So the minimum, first of all, could be anything, couldn't it? Could be anywhere in this array because we don't have any guarantees about anything. Like the minimum could be here. Like it could have been 1, 2, -3. That's what the user typed. Could have been like -10 at the end or something. Like the minimum could be anywhere. All right. So that's the first thing we notice. This will give us an algorithm once we write down what we see. So we have to, therefore, go through the entire array because any of those indices could be the minimum. It's not just like the first one or anything. So the min could be anywhere, so we have to check every index. So must check every index. Okay? Because the min could be anywhere. I hope that makes sense. And the minimum has to be one of these elements of the array, so you can't just like stick, all right, here's a good starting value for minimum, -100, because the user could have typed -500 or something, or the user could have typed all these and like the real minimum is 1 or something. Like this is too small. So like there's no good starting value. I guess there is a good starting value, it would be positive infinity, but we don't need to deal with that. So here's the algorithm. What you do is you just make a guess, right? You guess that the very first thing you see is your minimum, right? And this will eventually work as long as you update your guess. So guess that the 0th element is the min. Make a guess. Pretend that's true. So like you shove 1 in there if that's the very first value. All right? And then what you do is you go through the rest of the array and you update your guess as you need to. Update the guess as necessary. If you ever see anything smaller. So that's kind of why you don't want to like set this up as like -100 or something, because like you're going through this looking for something smaller, there might be nothing smaller. So a good initial value is a value that you have already, all right? So just make a guess, pretend that the very first element is your true minimum, then you go through every other element of the array, and do you see how like you compare it against your current guess for the minimum, and replace it if it's ever smaller. By the time you've checked everybody and like replaced with the smaller thing, you will have put the smallest thing in the min variable. All right, it's like in this case, like 1 is the true minimum. You try all these, you find nothing smaller, and then like you're done, and it really holds the minimum. But what if this was true? Like what if it was like instead of that one, that's like your first guess. What if it was 1, 2, -3? Then you try the 2, right? Okay, 2 is bigger. I'm fine. Then you see the -3 though, and you're like, oh, that's a better guess for the min. I'll replace. And then you try the rest of the array, and it never changes. Do you see how that's going to eventually, once you give everybody a chance, everybody a try at winning out for the minimum, it will hold the true minimum by the time you're done, right? Even if it was the last thing. It's like maybe it was 1, 2, -3, all the way to -10, like the -3 versus the 4, 5, 6 still is winning, right? 7, 8, and 9, they're still not smaller than the -3. But the second you see -10, it's like, oh, that's even smaller. I will replace. That's me updating my guess as necessary. By the time you're done, once you've given everybody a chance, your guess is correct. It is the true minimum. Does that make sense? That's a little bit of a complicated algorithm, but that will find the minimum for you. All right? And I think you can see how to do the maximum too, can't you? So, okay, let's code that up now. So let's get the minimum element out of this array. So what you do is you make a guess that the real minimum is like r of 0. It's the very first thing. This may be an incorrect guess, but we at least have a value of our array that we can check against. So guess that r of 0 is the real min. Now that may or may not be correct. That's fine. All right? We're going to let everybody have a try. And then I want to go through the rest of the array, so index 1 onwards, because like we've already put the thing at index 0 in min. We don't need to check that again. Go through every other index, so for int I equals 1 this time, right? I less than 10, I plus plus. What I want to do is update min if we see a smaller element. That's what I want, right? So if r of I is less than the minimum. So if the thing I see right now at my current index is smaller than my current guess for the minimum, like if it was 1 and I just saw -3, the thing I'm looking at right now at my current index is smaller than my current guess for the minimum, that better become my guess for the minimum. That's a better guess. Okay? So I want to set min to r of I. R of I is smaller. It's a better guess for the min. And as long as you keep doing this, given the smallest thing the rights to the min variable, by the time you're done, you gave everybody a chance. The true smallest thing is in the min variable. All right. So after this loop is done, after we visit every element, min holds the true minimum element of the array R. Isn't that cool? And let me prove that to you. We'll print it out. See how min : space whatever was in the min variable. And that should do it. So here, let's run it. Let's see if it works. I'll try all my options, right? Just like the 1, 2, 3, where the minimum element is the first thing. So cool, it just never updated its guess for min because everybody else was bigger. But let's try the others. Let's try 1 to -3, right? 4, 5, 6, 7, 8, 9, 10. It started its guess with 1, and then it eventually, when I was, 2, it found -3, and that was a better guess. -3 was smaller than 1, so it updated min to hold -3, and that won out against everybody else. And that was the true min at the very end. You see how it's working? It's just like the smallest thing is beating out everything else. So even with this, 1, 2, -3, 4, 5, 6, 7, 8, 9, and let's do -10. It went like this. It did exactly what I drew now. All right. It started with 1. It updated its guess when it saw -3. That was even smaller. And then once it saw -10, that was even smaller than -3, right? And so it replaced, because -10 was smaller than -3, it replaced min with -10. And that ended up being the true minimum. So that's a fun algorithm. I hope you can see how you can also do the maximum, just like flip this kind of comparison, huh? But yeah, that's a great example, I think, of a lot of things with arrays. So this is a good program to study. Do yell at me if you have any questions about it. But yeah, look at all the things we can do by making arrays with a bunch of values all of the same type, just in one spot. All right, so here is my question for you. All right, I want you to pause and think about, like, what do you think should happen here? I haven't told you exactly what's going to happen, but let's say we do this. Let's say I make an array in memory, int blah of size 6. Let's draw that out. So here's my array blah. I'll go back to blue. How many indices are in my size 6 array for blah, right? We've got 6 indices, right? 6. And what are the values? 0, 1, 2, 3, 4, 5, right? And let's say we try to do this. Let's say we try to run this code. Blah of 7 equals 42. What do you think is going to happen? Because, like, there's index 6, and we're going even farther than that. We're trying to go to index 7, which is not part of this array. What do you think is going to happen? All right, pause the video, try it out in code if you want to, but I want you to, like, think. What do you think should happen? All right. Hopefully it's C, right? If only. That's weird. Let's think about this. So this is me trying to go outside of the array. It's outside the bounds of the array, we say. So we're going out of bounds in the array. So let's see what happens. Let's do int blah size 6, and then what did I do with it? I said these things. Let me just paste this. My editor's warning me, even. All right, I get a runtime error. It does print 42, surprisingly. And then I get a runtime error. All right, it's like stack smashing detected, and then it stops the program because a horrible thing happened. So what I was doing, right, with this is I was accessing memory that was not part of my array, did not belong to me. All right, memory that does not belong to me. And so that's something you shouldn't be trying to access, but if you did, it looks like the answer is runtime error, maybe, right? Because it's gonna notice that. It's like C++ notices I accessed weird memory. It was unhappy about that, and so then it stopped the program with a runtime error. But it did print 42, so it actually did set the memory, which is scary to think about. So the answer might be A. Sorry, that might be B. But let me do something. All right. Let me add some more memory to this main function. Let's make an array of 42 chars, and I'll just sandwich the blah array. Make an array of 42 doubles, call it D, and then I'll recompile and rerun this program. Now it just prints 42. It does not have a runtime error. Oh no. So the answer is D. All right, the real answer is D, something else you don't know. It depends is the real answer. All right, so it's happy. It set something to 42, and it did not, like C++ did not complain. It did not stop the program with a runtime error either. What just happened was, I think you can kind of hopefully see what's going on in memory. Like, I made some arrays that sandwiched blah. Like, I put some stuff over here and some stuff after blah, essentially. That's kind of what I just did. And because of that, blah of 7 was memory that I owned still. It wasn't part of the blah array, but what I did here is I accessed essentially the memory of one of these arrays, one of these other arrays. And so I just messed with an index of one of these arrays, and I changed it to something very weird, because like the size of ints is not the same as the size of doubles or chars. Like I might have just messed with a bunch of indices at once, potentially. Crazy to think about, but like that's what I can do. And yeah, by doing this, by going outside the bounds of my normal array, I'm messing with somebody's memory, either my memory, some part of my variables that's not part of this array, or it's part of like C++'s memory, and like it's gonna get very angry at me. So like you don't have any control over that. Just never do it. All right. Sometimes it will work. This is a very common source of super subtle, horrible to figure out bugs, right? Because sometimes it works, sometimes it doesn't. This is made a change in some weird place in the program, right? That's disgusting. So never do this. That's why I spent a slide on it. What we just ran into is something called undefined behavior. All right. So this is just part of the language standard of C++. It says that if you ever try to do this, what happens is undefined. It's up to whoever made the compiler, essentially, to say what happens here. Because like you messed up so badly when you spoke C++. All right. So yeah, technically you can do it. You can access and set an index that doesn't belong to your array. If your array is size 5, it goes up to 4, you can access index 5. You can try. It might work, all right? But you should never do it, even though sometimes it works, all right? It's disgusting. It invokes the wrath of undefined behavior, and what undefined behavior means is part of the C++ language standard. It's like you broke the rules so badly that the compiler can do whatever it wants to your code. Like it can go, technically it is allowed under the language standard. Whenever I do a line like this, C++ is allowed to turn this code into code that deletes every file on my hard drive or something, or replaces it with cat pictures. Like that is technically allowed. That's what undefined behavior means. Anything goes at this point. I mean, it's a little bit more normal, but you could have done anything here. All right, so just be as scared as I am of undefined behavior. Try your best to never do this, but now you know, all right? Now you know. Please do your best to check the indices of your array. Don't try to go past, all right? Because you might run into weird bugs that sometimes don't even stop your program, all right? So that's as much of arrays that I want to get through today. I want to just pause here, and we'll come back with more arrays, and then I'll get into this new cool thing called vectors that kind of solves this problem in a way, actually. Vectors solve this undefined behavior problem in a neat way for us, but we'll save that for next time, all right? So I will see you in the next video.